Now, do you have to remember all of this stuff? No, but if I just said to you, oh, this is the integral symbol, and we start it here and we stop it here, and if I didn't explain all that rectangle business to you, you really wouldn't understand what this formula means. This formula really is finding a bunch of rectangles cut up so small that I can't even tell there's any gaps between those rectangles and the curves, and I'm finding the height and width of each rectangle. Okay. All right. How we doing? It's really a conceptual thing. Now, all we are going to do today then is when I ask you to find integrals, we aren't going to use a rectangle approximation anymore. I am going to give you things that you can find exactly. So if that's fair game, the only thing that I can ask you to do exactly is something we have an area formula for. So today's curves, when you make them with the x-axis, will be things like rectangles and trapezoids and maybe a semicircle. Okay, triangle. So let's do an example so you see how it works. If I said sketch a picture of the graph and we're going to shade the area and then evaluate the definite integral, what I would do is this 2 to 9, those are just the lower and upper limits. The 3, what's y equals 3? Horizontal line. Okay, so here's what this would look like. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. I'm going to draw a horizontal line. I would like to find the area between the curve and the x-axis.
May I have your attention, please? Due to evening events this evening and Thursday, the auditorium lobby will be closed for lunches today and Thursday. Due to evening events tonight and
Did you think we were getting let out?
The auditorium lobby
You
will
silly
be closed
kids.
for lunches today and Thursday. Thank you.
Thursday is the 5th grade program, and tonight is the band concert, both of which I will be at because I have children in them. All right, what shape is that? Rectangle. How could I find that integral then? I know the area of a rectangle. Let's find it. It would be what? Yep. What's the length? And what's the height? 3. The integral has a fixed value of 21. All right. This is an absolute value. Let's graph this. -3, -2, -4. 1, 2, 3. Okay, I'm going to just go ahead and graph it, and then I'll cut off the interval that I asked for. If I wanted to evaluate this from -2 to +1, how would you go about finding the area between that with the x-axis? We would use 2 triangles. Okay, so we want to make sure we do both of them. It would equal 1/2. What's this value? 2 times 2, right? Plus 1/2, because I'm doing the formula for area of a triangle. Are you following that? This one would be 1 times 1. That's 1. So let's see, 1/2 times 2 times 2 is 2, right? Plus 1/2 times 1 times 1, what's the area? 2.5. Okay. Now, dig way back to August when I had you fill out this concept sheet in chapter 1, and I said, you have to know all of these equations in general and what shapes they are. Most of them you probably remember. This one you might not, but maybe you do. I hope you do, because this is why you need to know now. What is this? It's a semicircle with radius 3. You got to know that. One, two, three, 1, 2, 3, 1, 2, 3. I'm going to just make sure that it hits those key points. I am evaluating the area from -3 to 3. Okay, what do we have? Half of a circle, so half of pi r squared. Agreed?
Yes.
All right, so pi times 3 squared divided by 2. I'd just leave that as 9 pi over 2. Now, where were all of these curves located? Above the x-axis. We should do one more example. I don't know if we're going to finish the whole thing. Remember how I said it's really not negative area, but the product is negative. So if we have it crossing the x-axis, we have to break it into above and below. So I'm going to show you this one. To make my life easier, I'm going to plug in the two values, okay, and see if I can figure out, are these all negative? Maybe they are. 3 minus 4, oh, this is all negative. 3 minus 4 is -1, correct? So this goes through the point 4, -1. Uh-oh, I'm going to go off the page. That's okay. How about 3 minus 8? -5, right? So let's see, this would be 5, 6, 7, 8. We'll do it down here. 8, -5. Looks like this. So if I was doing this one, what shape is this? Trapezoid. And the key, no! Why did I think I had 5 more minutes? It's okay, we'll pause. We'll pause.